5.1 vertical asymptotes. So just kind of look at the picture first, just staying basic. Let us examine the behavior of the function 1 over x squared. We know that 1 over x squared has an asymptote at 0 based on Math20 because 0 on the bottom is not allowed. So you can see the graph avoids that. Oh boy, I'm out of here. And then doesn't touch it because it can't have 0 on the bottom. So we can use limits, and we'll do this in a second, to figure out the behavior of where it's avoiding. So, for example, where's this going? By these numbers. Where's it going? Yeah, to pause infinity. It's going up forever. Okay? Just maximizing. Okay? All right, so the values in the table in the graph show the closer we take x to 0, the larger a 1 over x squared becomes. Now this would also make sense. Use your number sense. Numbers really close to zeros are really small fractions. 1 over 1 over 8 is 8. 1 over 1 over 100 is 100. You should know that from your, okay, I'm trying to show you here. Whoops. 1 over 1 over 100 is 100. Why? Well, think about it, right? You're flipping and multiplying. Just fraction work, okay? And that makes sense, right? Because if I divide a whole number by 100th, how many slices are in a whole? 100 of them. Okay, just fractions. Okay, so anyway, in fact, it appears that taking x close enough to 0, we can make f of x as large as we like. We indicate this type of behavior by writing the limit as x goes to 0 of 1 over x squared is infinity. Okay, because from both sides, it's going to the same spot. Right? Okay, and we say that x equals 0 is a vertical asymptote because it's never touching it. We can't put it in there. Okay, that's what the limit tells us. So notice that f is not defined at x equals 0, so f has a discontinuity at 0. Section 1.3, we know what discontinuity means. It means it doesn't continue. But the limit does exist there because why? Let's see if you remember chapter 1. Why does the limit exist? From both sides approaching the same value. The left side is 0 and the right side is 0 is going to the same spot, so the limit exists. Okay? So in general, the both sides of the number a, we write symbolically, it approaches infinity. Okay, we'll get to some where they don't approach the same, and we'll talk about that, but it still doesn't mean it's not an asymptote. The values of fx can be made arbitrarily large as we like, by taking x sufficiently close to a. So sometimes we'll test these. We'll take, you know, if we're going to 0, we can do 0.1 or negative 0.1, stuff that's really close to it but not quite it. Okay, so that's this type of limit is called the infinite limit. Roughly speaking, the values of f of x become larger and larger. As x gets closer to a, the symbol is infinity, not a number. Okay, so we usually read this as the limit of f of x as x approaches a is infinity. In this case that we just did, we were talking about 0. So look at these pictures to help illustrate what's going on. So this one, as limit goes to a, it's going to infinity. This one's infinitely going up. This one's a little bit steeper, but at the same time, it's still not crossing, and it's infinitely going up. The one on the right there, limit as f(x) x goes to a. For that example, they're both dropping, so they're both going to negative infinity, down and downwards. These figures illustrate the definition of infinite limit and similar type of limit denoted by x to the a with negative infinity. This is pretty simple stuff so far. Are we okay? All we established is they're positive, negative infinity. You want them to go together. Okay, for functions to become large negatives as x becomes close to a, similar definitions can be given for the one-sided infinite limit. So for example, the one-sided, remember, that means a from the left. From the left means over here, okay, from the left. Then we have a from the right, so on the right side of it, etc. Those are the notations from before one-sided limit. Okay, I pretty much just said what the bottom says there. If any of the four statements is true, okay, if any of these are true, that's a vertical asymptote. That's important. We are not defining a limit. We're telling if it has a vertical asymptote or not. So what that means is if I do 2 from the left and it's infinity, I do 2 from the right and I get like 4, let's just say it stops or something weird, it still is an asymptote there because it's not going to get us to the actual, it still goes up to infinity, which creates an asymptote no matter what side. So that's why it says one of the 4. Okay, so all I'm trying to tell you is I know that in the past, in our previous lessons, we said both sides have to be the same in order for it to be a limit. Okay, we're just trying to figure out if it's a vertical asymptote, and we're using limits to determine that. You understand the difference? Okay, so one of them. I'm just trying to make sure you don't understand it. Understand it's not both.
So if any of those are true, it's a vertical asymptote?
Correct. Okay, so here's an example of one. So limit x from the left is infinity. Picture. Limit a from the right, infinity. A from the left, negative infinity. A from the right, negative infinity. If any of these 4 are true, we have a vertical asymptote. All right, let's get to some examples here. I can pause it if you guys want to make the sketches here. Continue here. Let's get to the example. All right, so example 1. Find the limit, just the limit, okay, as x goes to 0 from the right and x goes to 0 from the left. So, in general, all we need to do here is we're just going to try some things to left and right. Okay, because remember, you're not going to have a calculator for this test. Okay, in terms of your graph calculator, you're like, oh, I'll just put in my calculator and see what the asymptotes are. Yeah, I understand that. Okay, but we're working on not doing that. That's why it's called curve sketching, not graphing. Okay, so 0 from the right means 0.1, 0.01. But we know that 1 over 1/10, 1 over 100th is going to be a whole number. So this one, we know right here, limit is x goes to 0 from the right of 1 over x equals infinity. Because I know my numbers in sense of numbers close to 0 from the right is 0.1, 0.01, 0.001, that's 1,000, that's 100, that's 10. As I get closer and closer to 0, it's getting higher and higher. Now conversely, x from the left is going to be negative numbers now. It's going to be negative infinity. So it's going to be 1 over negative 1 over negative 0.01, 1 over negative 0.001. See that? And the reason being, if you can see here on my notes, because 1 over x, you might remember, is a hyperbola. So this graph looks like this. From the right, infinity. From the left, negative infinity. Sound effects help sell it. Okay? If you're saying what graph did I just draw, that's what 1 over x would look like. Okay, any questions with that? So is x equals 0 a vertical asymptote? Yes. Because from the right of it was infinity and the left of it was negative infinity. Exactly, it still is to us. It's still not crossing there for some reason. Okay, good. And I put the picture on this one. That's the picture a little bit better. Okay.
When it has one of those, is the vertical asymptote at x?
It's 0.
Okay.
X equals 0. Because when x is 0, that's the problem as well. Okay, how about this one? Limit as x approaches 6. So yeah, we can't put 6 in. So we're going to try numbers on the left side of 6 and the right side of 6. But you have to understand what's going on here. 2 minus, so if I put in no matter what I put in here, let's say I put in 6.1. So that's going to be 6.1 minus 6.1 squared. That's a really small fraction, right? Are you staying with me? 5 over a really small fraction is a really big. So this is going to be a really big negative. 2 minus that big number. Do you see what I'm saying? 6.1. Now here's the kicker. Here's the kicker. Why is this one not going to be different? The last one was negative infinity, positive infinity. This one's both going to be negative infinity. Why? The square. Because if I put in 5.9 here, to get that negative 0.1, I'm squaring it, and I get that 1 over 100 again. Okay? So this, both sides, is approaching negative infinity. You guys got that? Okay, so I just put in my notes. If x is close to 6 on either side, it's a small positive number, okay, which we know if we did 6 from the right or 6 from the left, we're going to get infinity, negative infinity, sorry, because 2 minus that big number. And honestly, that's you do have to do a little bit of testing, okay? There's not like a simple formula here, okay? And I'll go on my little, I don't want to say rant, but we have to have a chat for this too, in terms of your test. Are we all right? That one's pretty straightforward. Do we get it again? Do you see the negative infinity? Everybody see it? Okay. So example 3, this is our last example. Find the vertical asymptotes of this function, x over x squared minus x minus 6. Sketch the graph near the asymptotes. All right, so first thing is, we do want to factor the bottom, because it helps us kind of see what we're testing. So, and if you know, I think you may know, maybe not, but if you remember from Math these are my asymptotes. We know that. It's 3 and negative 2. They're asymptotes. Okay? But we're going to use the limits to go ahead and kind of test that. We call them possible for us right now. You're going to be getting into more harder things, like it's giving you simple stuff. We're going to get into harder things where you actually they don't look automatic. But these are our possible vertical asymptotes of x, 3, and negative 2. So we are going to do limit x, 3 from the right. So 3.1. So if I do 3.1, just kind of playing with it, see what it does here. That's going to give me 0.1 times 5.1 over 3.1. So 3.1 over, we said 0.1 times 5, so that's going to be 0.51. What's going to keep happening to that number? So it's kind of, you got to kind of see the direction. I might not be selling it very well, but for me, immediately I see the bottom is smaller than 1. If the bottom is smaller than 1, what's happening? It's growing. Yeah, it's getting bigger. So to me, this is automatically is infinity. If you do 3.01, it's going to be the same exact thing, but this number is going to be smaller. If that's smaller on the bottom, it means we're getting bigger again. Okay, again, you can test these. I'm just saving us the punching in time. Okay, you can't have a scientific calculator when it comes to this test, though. Just not graphing. Okay. Okay, so we got to think of that. If x is close to 3 but less than 3. So if x is close to 3 but less than 3, so on the other side, doing the left of 3, so 2.9, now it does everything the same except for makes it negative, correct. Then let's look at negative 2 from the right. Negative 2 from the right would be like a negative 1.9. see that? Negative 1.9. If I put negative 1.9 here, that's going to be 0.1. That's going to be a negative 4, but also a negative. So it's going to be a big positive. So let me show that again. So this one here, if I put negative 1.9, it'd be negative 1.9 over a negative 4.9 times 0.1. So this is going to make that smaller. Negative over negative is positive, so this is another positive infinity. And then conversely, from the left will be the negative infinity for the opposite reason, because we'll get this as negative. What I do in my notes, in terms of not doing the numbers, I write it out like this. I'll just write it out once for you, this one. I have a negative over a negative and a negative. And then I thought, is it getting bigger or smaller? That's what I do. So this means if I have 3 negatives, I have a negative, and it's getting bigger because the numbers on the bottom are smaller. Okay. Good. So we've confirmed that we actually got all 4 for both spots. So we just confirmed that they are vertical asymptotes. Okay. I won't sketch the graph. The graph you can sketch if you'd like. I don't think I put it on here. Maybe I did. Yeah, I forgot. So the graph's in the book if you want to take a look at it. It's just has those 2 asymptotes, and it has the s's going through them. Okay. All right, that's it for this one.